National Chemistry Week. My name is Caroline and I am a graduate student at Purdue University. Today I want to share with you the science behind chemical reactions. Reactions are when more than one chemical combine and transform into a completely new chemical. Isn't that crazy? Chemical reactions can occur in everyday life, such as baking, burning a candle, or even digesting your food. And these reactions can occur at different speeds. But what makes them go fast or slow? Can we change the speed of these reactions? Stick around and we'll learn this and so much more. If you are in the greater Lafayette area, you may have received one of these science kits from school with all the required materials. But if not, you can find all of these materials at home or at your local store. So let's unpack our science kit. You will find a half lemon and a half orange, a bottle of water, a jar of canola oil with some food coloring in it, a bag of baking soda, 3 plastic cups, a glow stick, a plastic spoon, 2 packets of effervescent tablets, and a sticker with our logo on it. Let's first discuss how chemical reactions happen. I'm going to explain this using balloons! The chemicals that we start with are called reactants, which we're going to represent with this blue and yellow colored balloon. When the reactants collide, they will form what we call products. Our new chemical, like our new green balloon. And the speed of the reaction and the formation of these products depend on how often the reactants collide. So if the reactants collide often and frequently, we will have a fast reaction. But if the reactants don't collide that often, we will have a slow reaction. So let's learn about the factors that affect how often reactants collide. And we're going to first learn that from Sam.
Hi, I'm Sam. The first factor that affects the speed of a reaction is the amount of reactant. Different amounts, more or less, can cause the reaction to go fast or slow. But why does that happen? We're going to do a fun experiment to find out. In your bag, locate the lemon and orange halves. Please don't eat the fruit because we're going to make volcanoes out of them. You're also going to need the bag of baking soda as well as the spoon. Place the lemon and the orange face up on the table in front of you. With the spoon, scoop out some of the lemon and the orange, basically just squishing out the juice. Make sure you do keep a lot of the juice in the lemon and the orange if you can, because we need that for our reaction. Next, take your bag of baking soda and scoop some of it onto the lemon and the orange, and try to make it as even as you can. If you want, you can poke the lemon and the orange just to get a little more of the juice out after putting the baking soda on. Look, we have fruit volcanoes. They're erupting. Look at them go. But why is this happening? Chemistry. The citric acid in the juice of the fruit is reacting with the baking soda, otherwise known as sodium bicarbonate, to produce carbon dioxide gas. That's what those little bubbles are, carbon dioxide. Which fruit volcano is erupting more, the lemon or the orange? My lemon volcano is erupting a little more than the reason is that the lemon has more citric acid in the juice than the orange does. If you've ever bitten into a lemon before, you'll know that it's really, really sour. What you're actually tasting is the citric acid in the lemon juice. While an orange also does have citric acid, it has a lot less, so it really doesn't taste that sour. The citric acid is reacting with the baking soda, and because the lemon has more, it has a better reaction, or a faster reaction. If there are more reactants in a chemical reaction, they'll be more likely to collide with one another. If we have more collisions, then we'll have a faster chemical reaction and a more violent volcano eruption. Let's pretend that this yellow balloon in front of me is a citric acid molecule, and the two balloons I'm holding are our baking soda molecules. So when the baking soda collides with the citric acid, it produces a CO2 molecule, which is what the blue balloon is. So now we have more citric acid molecules like we do with our lemon. So now when the baking soda collides with this citric acid, we produce more CO2. So don't forget, a larger amount of reactants makes a reaction go faster. Isn't that cool? Now you know how the amount of a reactant can speed up or slow down a chemical reaction. Let's move on to our next factor, temperature. Take it away, Caroline.
Hi, me again. This time I'm going to talk to you about temperature. Temperature is how hot or cold something is, like air or your body. And temperature actually affects the speed of reactions. Think about heating up your oven when you're baking a cake. The high temperature allows the ingredients in your cake to react and your cake to rise. But how does a different temperature affect the speed of a reaction? Let's do a little test and find out. Inside your science kit, you will find a glow stick. Now you may have seen these before either at a party or at the dollar store, but you may not know how they work. A glow stick contains 3 chemicals. It contains hydrogen peroxide, phenyl oxalate ester, and a colored dye. Inside the plastic casing of the glow stick, there is a glass vial containing hydrogen peroxide. When you bend the glow stick and break the glass vial, the hydrogen peroxide comes out and reacts with the phenyl oxalate ester, and this reaction produces a lot of energy. And the energy is then taken by the colored dye, and then the dye glows with the energy. Now hold your glow stick up to your ear and start bending it. Listen to the cracking sound. Now look at your glow stick. It should start to glow. And now continue breaking it until the whole thing is completely glowing. Your glow stick will continue to glow until all of the chemicals inside of it have reacted. For our temperature test, I want you to take the glow stick and hold it really tight in your hand, or squeeze it, or twist it around. Now we're going to do this for 10 seconds. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let go and quickly look at your glow stick. What do you see? It should be glowing a little brighter where your hand was. But why does it glow brighter there? The answer is temperature. Your hand and your body are about 98.6 degrees Fahrenheit, while the room temperature around the glow stick is about 70 degrees Fahrenheit. Your hand is hotter than air. And when you hold the glow stick tight and warm up the reactants inside the glow stick, they move faster and make the reactants collide more frequently. This makes the reaction go faster and your glow stick glow brighter. The opposite will happen if you put the glow stick in a refrigerator or in a freezer. The lower temperature will slow down the reactants and cause them to collide less frequently. This will make the reaction go slower and your glow stick glow less. So remember, high temperatures make reactions go faster and low temperatures make reaction go slower. So let's learn more from Jennifer.
Hi, I'm Jennifer. Our last factor of what affects speed is surface area. You may haven't heard what surface area is. Surface area is the total area outside of an object's surface. For example, look at this balloon. All the outside of this balloon is its surface area. And if we have one big balloon and many small balloons, the surface area of a small balloon will be bigger than that of a bigger balloon. The same concept applies to tablets and powders. In your science kit, you'll find 2 tablet packets. These are effervescent tablets that can be used to cure a bellyache. It contains the chemical citric acid, sodium bicarbonate, and when they're dissolved in water, they'll start to react. What is going on here is that the water will start to fizz a product, and this product is called carbon dioxide. Also, carbon dioxide is the same chemical that we breathe out. In your science kit, find the effervescent tablets, 3 cups, and a water pump. Fill each cup about halfway. Put the bottle back in your kit or aside and save it for later. Open one of the packets. Take one of the tablets out. Then take the other tablet out and break it in big chunks. Okay. I don't know if you can see it from here. Now open your second packet and remove only one tablet and put it aside. The tablet that remains in that packet, you're going to crush it and break it in very small pieces. Now put the whole tablet in one of the cups. The smaller pieces in the middle cup and the one in the packet that you have break down, put it on the third cup. Now watch this. Did you notice any difference between the cups? Which one fizzed the most? By my observations, the third cup was the one that fizzed the most, and the first cup was the one that fizzed the least. But why is this so? Surface area. The tablet that was broken into tiny pieces had the most surface area, and the whole tablet had the least surface area. The increased surface area provides the chemicals with more space to collide with each other, hence speeding up the reaction. So remember, more surface area, more collisions, faster reactions. Now, Sam is going to help us with a craft.
Now we have learned about the 3 factors that can affect the speed of a chemical reaction: amount, temperature, and surface area. Let's use our knowledge to make our very own lava lamp. So find the jar of oil that has some food coloring at the bottom of it in your science kit, as well as the bottle of water that we used earlier. Open the jar and put some water into it. You're going to want to fill up the jar pretty much to the top, but not all the way, just so there's enough water so you can see what happens. You might have to wait a couple minutes after we swirl this just for the layers to separate, but the water is going to be what's colored. And it'll be on the bottom because water is heavier than the oil. Next, find your last effervescent tablet and plop it in your jar. Once it hits the water, it'll immediately start to bubble. Bubbles of carbon dioxide gas will start to form and make your lava lamp go. Isn't that pretty? Your lava lamp will continue to work so long as there are chemicals in the jar from your effervescent tablet. Once the chemicals are gone, the reaction will stop and the lava lamp will stop working. You can take this home to show your family, and if you want it to start working again, just plop another effervescent tablet in, which is also known as Alka-Seltzer, and the reaction will start all over again. So now I'm going to throw it over to Caroline.
Wow, isn't chemistry amazing? We learned that we can change the speed of reactions by changing the amount, temperature, and surface area. So next time you see a chemical reaction in everyday life, such as baking or medicine, remember what you learned here today. Thank you for joining us in celebrating National Chemistry Week. Share your science fun with us by using the hashtag NCW2021 and hashtag ISPPlutonium, and tag us at ISP Plutonium on Instagram, Twitter, and Facebook. Have a great day, and remember, fast or slow, chemistry makes it go.